All right, welcome back. In this video, we'll keep working on example 8.1.7. We had started looking at the Mirabel company that could build two types of kayak, the relaxed kayaks and the adventure kayaks. We had set up the linear programming problem, and we also set up the initial tableau of the simplex method. And now we're off to part C. We're given the reduction here. And we're asked, and I explain why this tableau represents an optimal solution and give this optimal solution. All right, let's see. We know we're at an optimal solution if the bottom row has no negative entries, which is clearly the case here. So the bottom row has no negative entries. And so this tableau is optimal. And then once we have to figure out what that optimal solution is, we divide the variables into two types. The columns, which only contain the one, those are basic variable, and we read their values right here. So we get that x is 8 from the first row. From the third row, we get that y is 14. From the bottom row, we get that the profit is $8,000. So the company should build 8 relax and 14 adventure kayaks for a profit of $8,000. All right, so this is an optimal solution. That's the maximum amount of profit that it can get. Notice that we get more information here. We also get how much resources are left over. So these two are non-basic, and so that means that S1 is 0, S3 is 0, and S2 we got from the basic variable, it was equal to 50. And so this means that we have 50 square meters left of the first resource, of the second resource, which is fiberglass. The carbon fiber and the man hours are completely gone. All right, so we're asked to pivot on S3, and we claim that we're going to get a second optimal solution, and we're asked to give that optimal solution. All right, so I'm going to pivot on S3. It's not a negative entry here, but it's not a positive either. It's a 0, and that means that we're probably not going to change the bottom row when we pivot, and so we're not going to change the profit. All right, so let's see what the ratios give us. It's always the constants over the column on which we pivot. So here it's 8 over minus 1/5. It's minus 40. Negatives not allowed. This one is 50 divided by 50/4. That's 40. This is fine. We just don't know if it's the smallest. And then the final one is 14 divided by 3 over 20. That's 280 divided by 3. How much is that? 93. All right, so this is the smallest, and so that's the one on which we'll pivot. All right, so we're pivoting on the S3 and on this entry, and that means our pivot is this 5/4 right here. So I'm going to start by dividing R2 by 5/4. Nothing else will change, so all of these rows are fine. 0, 0. And here, if I divide, that's like multiplying by 4/5, I guess minus 3 over 5. Here I get 4/5, here I get 1, and then we said we get 40 right here. The bottom row doesn't change. and the fourth row doesn't change either. All right, we're halfway through a pivot. Now we need to clean up the column. So I'm going to take that one that I just created and use it to get rid of the minus 1/5 and use it to get rid of the 3 over 20. So I'm going to get row 1 plus 1/5 row 2 to row 1 and row 3 minus 3 over 20 row 2 to row 3. All right, don't hesitate to use your calculator here if you need it. 2 over 25 minus 3 over 25, that's minus 1 over 25. Here I'm going to get 4 over 25. I'm going to have 0, 0, and then this one will actually increase. I'm going to add 40 over 5, I'm going to add 8, so I'm going to get 16. Second row, we're not touching. And third row, all right, let's do this. 0, 1, minus 100 plus 9 over 100. So that will be 8 over 100. We could leave it like that. I'll probably want to simplify to 2 over 25 if I need it again. And then here, that will be minus 12 over 100. Again, I could simplify this. 0, 0, and then 40 times, that's minus 6, and so 14 minus 6 is 8. All right, this is what I get, and the bottom one, again, we don't touch because we already had a 0. And so you can see what's happening here. We said that if there's a negative entry, we need to pivot because that would give us a bigger profit, a bigger objective function. If you have a negative, positive, you don't want to pivot because that's going to give you a smaller one. But here we have 0, so we stay at the same level. All right, so we've pivoted. Now this row has no negative entries. And so this means we are at an optimal solution. Let's read these solutions. We have, let's use the same color. So we have 2 non-basic and 3 basic variables. We're getting, so this is x, y, s1, s2, s3, and p. We're getting from the first row, x is 16. From the third row, y is 8. And then from the bottom row, P is still 8,000. So what's happening here is that there actually are 2 different ways of getting the same $8,000 profit. If you care about the resources, there's no fiberglass or carbon fiber left, but there is some hour left. All right, so here the company should build, let's put could also build 16 relax, and 8 adventure kayaks for the same $8,000 profit.